Welcome back. For each of these sets of premises, what relevant conclusion or conclusions can be drawn? Explain the rules of inference used to obtain each conclusion from the premises. A. If I play hockey, then I am sore the next day. I use the whirlpool when I am sore. I did not use the whirlpool. Let P be the proposition I play hockey. Q be the proposition I am sore the next day. R be the proposition I use the whirlpool. What are the premises? I play hockey implies I am sore the next day. I use whirlpool, when I am sore, then I use the whirlpool. You see, I use the whirlpool when I am sore. So if I am sore, I use the whirlpool. I did not use the whirlpool. Negation of R. Negation of R implies negation of Q, that is by modus tollens. Negation of Q results in negation of P by modus tollens. So the conclusion is I did not play hockey. Okay, negation of P. B. If I work, it is either sunny or partly sunny. I worked last Monday or I worked last Friday. It was not sunny on Tuesday. It was not partly sunny on Friday. Let P be the proposition I work. Q the proposition it is sunny. R be the proposition it is partly sunny. If I work, then it is sunny or partly sunny. Well, I worked last Monday or I worked last Friday. For this premise, a valid conclusion therefore is it was either sunny or partly sunny on last Monday or on last Friday. Okay. It was not sunny on Tuesday. Okay. It was not sunny on Tuesday. Well, then a valid conclusion is I did not work on Tuesday. Well, what if I did work and it was not sunny? Then it was partly sunny on Tuesday. So, conclusion is I did not work on Tuesday or it was partly sunny on Tuesday. It was not partly sunny on Friday. If that's the premise, then either I did not work on Friday or it was actually sunny on Friday. Okay. C. All insects have 6 legs. Dragonflies are insects. Spiders do not have 6 legs. Spiders eat dragonflies. Okay. Valid conclusion. Dragonflies are insects. Well, all insects have 6 legs. Therefore, dragonflies have 6 legs. Okay. Spiders are not insects. Well, spiders do not have 6 legs. If spiders were insects, they would have 6 legs. Spiders eat some insects because dragonflies are insects. Spiders eat dragonflies. So spiders eat some insects. D. Every student has an internet account. Homer does not have an internet account. Maggie has an internet account. Well, Homer is not a student. If Homer had been a student, he would have an internet account. Homer does not have an internet account, therefore Homer is not a student. But notice, we cannot say anything about Maggie. We know Maggie has an internet account, and we know every student has an internet account. But Maggie could very well be somebody else, a staff member or a faculty member. So there is no, you cannot conclude, there is no valid, it's not a valid conclusion to say that Maggie is a student. Okay. E. All foods that are healthy to eat do not taste good. That's a premise. Tofu is healthy to eat. You only eat what tastes good. You do not eat tofu. Cheeseburgers are not healthy to eat. Well, all foods are healthy to eat, do not taste good. Tofu is healthy to eat. Therefore, tofu, a valid conclusion is tofu does not taste good. You only eat what tastes good. Well, you do not eat foods that are healthy because healthy do not taste good. So, if you eat what tastes good, you do not eat foods that are healthy. You do not eat tofu. Well, it gives you no valid conclusion. Cheeseburgers are not healthy to eat. It doesn't generate any valid conclusion. You see, healthy do not taste good, but there is nothing here about not healthy. You see, not healthy may also not taste good. Okay, so there's nothing to conclude about cheeseburgers. The last example, I'm either dreaming or hallucinating. I am not dreaming. If I'm hallucinating, I see elephants running down the road. Well, I'm either dreaming or hallucinating. I am not dreaming. So I am hallucinating. You see, I am not dreaming. I'm either dreaming or hallucinating, but I'm not dreaming, you see. So I have to be hallucinating. If I'm hallucinating, I see elephants running down the road. Well, I am hallucinating. Therefore, I see elephants running down the road. All right. So these are the conclusions you can draw. To construct proofs in propositional logic using resolution as the only rule of inference, the hypothesis and conclusion must be expressed as clauses, where a clause is a disjunction of variables or negation of these variables. So only rules of inference, all right, using resolution as the only. Look at resolution. You have 1, 2, and 3. You see, 3 propositions to play with. Let's see. Show that the premise P and Q or R and R implies S imply the conclusion P or S. Well, indeed, what is P and Q or R? These are the two clauses. This entire expression, there are two clauses here. P and Q or, sorry, P or R and Q or R. R implies S. Negative R or S. See, this is equivalent to saying negative R or S. Okay. Now, P or R and negative R or S, well, concludes P or S by resolution. All right. So that's what we are looking at. Fallacies. Several common fallacies arise in incorrect arguments. Example. Consider the proposition P implies Q and Q implies P. Well, this is not a tautology. Well, if P implies Q and Q is true, doesn't mean P is true. For example, when P is false and Q is true. When P is false and Q is true, well, when P is false, this P implies Q is true, and Q is true if Q is true. So this would be true, but P is still false. All right. So such an incorrect reasoning is called the fallacy of affirming the conclusion. Here is a concrete example. If you work hard, so P is you work hard, Q is you will be rich. So if you work hard, then you will be rich. Now suppose you are rich, that is Q is true. Well, can you conclude that you must have worked hard? No. You could be rich by just inheritance. You may not have worked hard at all. So P implies Q and Q does not imply P. Okay. Similarly, the proposition P implies Q and negative P implies negative Q is not a tautology. It is false when P is false and Q is true. If P is false, P implies Q is true no matter what Q. Now, if Q is true, P is false, negative P is true. So this entire expression is true. Q is true, negative Q is false. So how can you conclude from here that Q is negative Q is true, right? So many incorrect arguments use this incorrectly as a rule of inference. Such an incorrect reasoning is called fallacy of denying the hypothesis. All right. So negative P, so that's hypothesis. Negative P is denying the hypothesis. All right. Here is concrete example. If you eat an apple every day, then you will keep the doctor away. Okay. Suppose you do not eat an apple every day. Does that mean you cannot keep the doctor away? No. Just because you could have other means of keeping the doctor away. Yes. So be mindful about these fallacies. Okay. That completes lesson 6. Next video will continue with lesson 7. Until then, bye.